Alright, let's look at this problem. So this one, it doesn't seem to fit the pattern of difference of squares. If it kind of looks like it has potential of being something that you know, but it's not quite like that, this is a clue to look for a greatest common factor. You should be doing that anyway automatically. But let's see, I see that they have y squares in common. And I think they both divide by 3. Right? So we're going to factor out the greatest common factor, 3y squared. 48 divided by 3 is 16. We get x to the 4. And then minus 81. Alright. Let's see, so we have 3y squared. So this looks like difference of squares now. Let's split it up evenly. 16x to the 4. And don't worry, that's x to the 4 because we can split it up into 4x squared and 4x squared. Right? And then the 81 is plus 9 and minus 9. Alright. Now you might think that we're done here, but we're not. We basically want to factor completely, which means if any of these parentheses can still be factored, you will. Okay? So if I look here, this is not a difference of squares, the sum of squares. A squared plus b squared, this does not factor. Okay, so this is a prime thing. With the minus it factors, but with the plus it doesn't. So this is as factored as it can be. But this one is a difference of squares. Right? That means that I can break that up even more. So we're going to keep the 3y squared and then 4x squared plus 9. And this one, it splits into 2. 2x times 2x from the 4x squared plus 3 and minus 3 from the negative 9. Okay, now we're done. Right? So especially if you start with like higher exponents, potentially sometimes you need to factor several times until you get to factor completely.